The lever family, we are finishing off with the pulley, one of the easiest to actually calculate, so this shouldn't be too bad. So for me, I've actually got some extra space down here, and I want to start pulleys on their own page, so I'm going to go ahead and put a line through there. Please remember to sign and date, and have a classmate sign and date that they've read and understood this page. All right, so we're moving on. Make sure you get your page number at the top. And this is page 3. Isn't it page 3? Yeah, it's page 3 of our notes on lesson 3. So this is pulleys. There we go. Alrighty, so with pulleys, basic definition is a wheel with a groove. It doesn't necessarily have to have a groove, but it's going to work a lot better if you have a groove. And we're using it to change the direction and magnitude of a force. So you've probably seen pulleys like this before. You might have a pulley in your window blinds. Oh God, where else are pulleys? Pulleys are all over the place. They're in the equipment that you see at the gym, all kinds of different things where you're going to be using pulleys. And honestly, if you get into some robotics, you'll probably see some pulleys in there. We're going to talk about the two main types of pulleys and how we calculate the IMA of a pulley. Sorry that keeps going in and out. I'm going to try to see if it's a little blurry when I try to put the focus freeze on, but that doesn't look too bad. I'm going to go ahead and leave it there. Okay, so two main types of pulleys. We have the fixed pulley and the movable pulley. Okay. So the first one here, that's the fixed pulley. Fixed meaning, see how there is a thing to attach it to the ceiling up here, like a hook? This pulley is going to stay stationary, connected to the ceiling or the roof or the crane that is holding it. Your fixed pulley is basically a first-class lever. And that is because you can see that the fulcrum on this pulley, there it goes, is right here in the center. That's where things are being rotated from. And the IMA is going to be equal to 1. And let's go ahead and draw that fixed pulley. I'm going to try to make mine look a little bit like this. And here's my little wheel sticking out. That's supposed to be my little pulley wheel on the outside there. And then we've got our fulcrum is the axle of the pulley. And then you can see that this, as long as this is symmetrical, which it should be because it's a wheel, then you're going to have your resistance force, FR, whatever that load might be. Here in this example, it is a 10-pound weight. And so then on the other side, you're going to be pulling with an effort force of 10 pounds. Because all we're doing is changing the direction here. The benefit of this is that you can pull downward and have gravity help you with pulling. If you were trying to just lift this up, you'd have to just be fighting gravity, but this gives you a little bit more leverage because you're getting to pull downward with the force of gravity. Okay, so that is all we're doing here is changing direction. Allows us to pull down with gravity instead of fighting against gravity. All right, now our movable pulley. So in the movable pulley, you can see that there is something that one side, one rope is connected to, and then the force is actually acting down the opposite direction, and we're pulling upward on this one. So this 10-pound weight, the weight is actually getting distributed between these two strands. Here, all of the weight is being supported by one strand, and so that's where we get this IMA of 1. And then here, weight is being distributed by 2 strands. That's where we actually get the IMA of 2. We can also see that this is a second-class lever. Our effort force is acting out as far away from the fulcrum as possible. So if we look back at our second-class lever, the resistance force is in the middle, just like this 10-pound weight is in the middle, and the effort force is on the outside. It's as far away from the fulcrum as possible. So the effort, or the resistance force, is between fulcrum and effort. That's what makes this like a second-class lever. Okay, so then let's go ahead and sketch this one. I'm gonna have my roof, I guess I should say second class IMA equals 2, and then this is 5 pounds, and the width of my pulley. I'm gonna make it kind of a big fat one just so that I can write all of these little things. And then I'm going to put that this is the effort force is equal to 5 pounds. So you're actually just going to apply 5 pounds because basically the ceiling is supporting the other 5 pounds, like here and here. And then I'll go ahead and draw in my pulley. It's a big fatty, isn't it? Looks like a hot air balloon. How lovely. Okay, and I'll draw my little example lever here. Okay, I think we've got everything right. And then the force direction actually is staying constant here. So we're not, we're pulling against the 10 pounds, but we're not able to, it's not allowing us to change the force or the direction. Because if we were going to lift this guy up, we'd have to pull up anyway. Okay, so that's everything on those two main types, your fixed and movable pulleys. Now, we got to get it in, so, well, let me actually back up here. So the big trick, IMA of a pulley is equal to the number of support strands. I put strands. Okay, so when I say support strands, you couldn't read that at all. There you go. IMA is equal to the number of support strands for a pulley. Here, the only support strand is just this one strand that I'm pulling on. This is where the weight is being held on this strand. It's actually the same rope. So this is only one support strand, IMA of 1. Whereas over here, this is technically one rope that is going all the way around this pulley, but we're supporting in both of them. The weight is being distributed between the both of them, so we would say that that is 2 strands. Okay. Now, IMA of a pulley, it is just number of strands opposing the load. So that's another way of putting this. Number of, or you could say number of strands supporting the load or opposing the load. All of those might be better ways of phrasing that. All right, so now we've got a real complex one. And let's see if we can actually figure out how many support strands there are. So how many strands are actually being used to support the load here? Well, what I like to think of is the one that the one that you're actually pulling on, where you're applying your effort force. I basically just don't count that one, and then I count the rest of them. If I'm pulling it down with gravity, then I don't count that one. If I'm pulling up against gravity, then if I'm supporting against gravity, that counts. But if I'm pulling down with gravity, that doesn't count. So I have actually 1, 2, 3, and 4 of these that are going to be supporting the load. And so that is actually going to be an IMA of 4. Now I do want you guys, I know that this is not going to be the easiest thing to sketch, but we're going to sketch it. Go ahead and sketch that ceiling, those lines there. It's kind of like a cross section showing you that that's the ceiling. And then I'm going to draw my 4 circles, and then if you just make the ones on the outside a little bit bigger than the ones on the middle, it's going to be easier to sketch. Okay. How about I do blue to represent this? So the rope actually starts right here in the middle. Do a little, these 2 are connected, and then these 2 are connected, and then we actually have our little load way down here, and that is 600 pounds. And then we'll do, starting from here, we're going to go around the little one, and then around the top little one, and then we're going to go around the big one, and then the top big one, and then this one. This is our effort force here, and this is, let me get a purple, FR is equal to 600 pounds. It's hard to see it down there over the PLTW logo. Okay, so then my support strands are going to be, let's do 1, 2, 3, and 4. There we go. So this is an IMA of 4. So IMA equals number of support strands. That is my formula. Substitute. And solve. Is you're just counting the support strands, and it's 4. That's it. And since this is mechanical advantage, there is no unit again. So that's our final answer for the IMA of this combination pulley. Okay. Now we've got a little compound machine here. So we're going to see what's going to happen if we put 2 simple machines in use together.